is just talk about what a logarithm is. So with a log, you will see the word log, and we will talk about a base with that. The base has to be a positive number other than 1. So if I see this expression, I read that as y equals log base a of x. You can rewrite a logarithm as an exponential. The base of the log is the exact same as the base of the exponential. And then you just go across the equal sign. So it's a to the y power equals x. So that's how we go back and forth between the log and the exponential. When we talked about exponentials, we saw that when you did a number to a power, you only got positive answers out. So that tells me with the log, my x has to be a positive number. So your domain, your x has to be greater than 0. The argument of the x must be positive. So both the base and the argument are positive here. So I want to first start out just going back and forth between the two notations. If I have something in exponential, 1.2 to the third power equals n, you can write that with a log. So you write the word log, L-O-G. The base of the exponential is the base of the log. That is a subscript. Okay, so it's not a full-size 1.2. It's just a small 1.2 down to the side. Then you go across the equal sign. So it's log base 1.2 of m, and the answer to the log is your exponent. So equals 3. For b, if I have a log and I want exponential, you always start with the base. So this is base e, so it's e to the negative third power equals b. I want you guys to do c and b. So the first one should be 3 to the c power equals 5. The last one will be log. You start with the base, so log of base 3, go across the equal sign, of 9 equals 2. Are there any questions about going back and forth between these notations? Yes.
Or you guys are wrong,
So if I said 32 equals 2 to the 5th, it would be log. What's the base of my log going to be? 2. Of 32 equals 5. So you always go across the equal sign. So the answer to a log is an exponent. When I see this, it's like saying 2 to what power equals 32? It's the 5th power. So I want to start evaluating some logs. There are 2 ways to do this. Some of you might be able to look at this and just know the answer to the problem. When I say log base 2 of 16, the answer to a log is the exponent. 2 to what power equals 16? 4. So the answer is 4. You have to be careful on the calculator. The log button on your calculator is base 10. So if you just push that log button and 16, it will give you the wrong answer. We want log base 2, so we have to do it on our own. So the answer to this, you might look at it and just know is 4, but if you didn't, you could always make a problem out of it. Say it equals x, I don't know. Then write it in exponential form. 2 to the x power equals 16. Weren't we solving problems like this on our test? Yeah, we would get a common base. 16 was 2 to the 4th, and x equals 4. So if you know it, great. If you don't, change it to an exponential and solve it. So B, 3 to what power equals 1 over 27? Negative 3. Does anybody need me to write it out as an equation and solve it that way? C, log base 2 of 1. Yeah, it's saying 2 to what power equals 1, so that one is 0. All right, D, log base 5 of 25. 2. 5 to what power equals 25? That would be 2. Let's do some where we can't necessarily just look at it and solve. So log base 3 of 4x minus 7 equals 2. So if I wanted to solve this, I would have to change it to exponential. So I'm going to make it 3 to the second power equals 4x minus 7. So 3 to the second is 9. Add your 7 over. Divide by 4 and you get x equals 4. You do have to check on these because in a log both the base and the argument have to be positive. So you do need to make sure if I plug a 4 in here, is 16 minus 7 positive? Yes, so I'm okay. So just check that you're only getting a positive for your argument. So B, this would be x to the second power equals 64. How do you get rid of a second? Square root. With it, we do. The square root of 64 is 8. Okay. Is positive 8 an okay answer? Is negative 8? No. The only thing that can be negative in a log is what it's equal to. Base and argument have to be positive. So my only answer here is the positive 8.
Is it always going to have to be positive?
Yes, but you have to be careful. If this had been written like log of the opposite of x, then your answer would have been the negative 8.
So can you just look at the, I could just tell that it was 8. Is it always, like, the top one is always going to be positive and the second one's always going to be negative? Like if it has that negative, okay.
Other questions there?
You count all the you just.
If it's one like this that you could look at it and know, that's fine. keep solving these. So some of them you might be able to look at and know, some of them you may not. If I did this one, how would I write it? Then what would you do? Okay. A negative power would change course. Then what could we do? Sure, we could cross multiply. So that would be 16x squared equals 9. So x squared equals 9 over 16.
What did I use for that?
Cross multiply. Get rid of a square, you square root plus and minus, you get x to be positive and negative 3/4. Are both of those okay? Just the positive.
So to get your so x and negative 2, you always go across. So whenever it equals, it's always going to be the power.
Yes. Why don't you guys try these two? First one, if you rewrite this, you get 16 to the 3/4 power equals x. That's like saying the 4th root of 16 cubed. So you should get positive 8. And 8's an okay answer, so we're done. C, this says 36 to the x power equals the square root of x6. I saw two options here. Some of you squared each side to cancel the radical and made it 36 to the 2x equals 6. And some of you just dealt with it. Either way is fine, but we have to get a common base no matter what. 36 is 6 squared. A square root is a 1/2 power. So 2x equals 1/2 and x is 1/4. Yeah, if you squared it first, you would get 36 to the 2x equals 6. Then you would rewrite this as 6 squared to the 2x equals 6. So 6 to the 4x equals 6 to the first. 4x equals 1 and x is 1/4. So same answer, two approaches. Are we doing okay with this? Okay. I'm going to go to this example, I believe. I just want to make sure you know how to plug these things in your calculator. You have two different logs on your calculator. There's the ln, which, if you remember from Algebra 2, represents the natural log. We will talk more about that in the coming days. And then there's an log. That means your log base 10. So again, we will look more at those later on, but I just wanted to make sure you could evaluate each of them. I'm actually going to change this one, I think, to be. Okay, so if I said ln of 46, if I just want you to evaluate that on the calculator, I just want to make sure you know, find your ln button, type in your 46. I prefer 4 decimal places when you do that. Round as needed, so you should get 3.8286. Did everybody get that? The second one, I changed that. I want log, so I just want you to use the other button. So log 8 times e to the 6th power. So let's just make sure we can plug that in. Round 4 decimal places. Should get 3.508.
1 over 8. 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 1
Does anybody have issues putting those in? The last thing I want to do today is talk about properties of logs. So we're going to write down all of the properties. I'm only going to do a couple examples with them today, and then we'll pick up using those properties tomorrow. So we'll expand on it tomorrow. So our properties. You don't necessarily have to write down this line. It's just telling you that everything's positive, which we already know in a log. The product property says if you have the log of things being multiplied together, you can split it up and do the log of each one added. If things are being divided, you can subtract their individual logs. And if you have the log of a number to a power, the number turns into a coefficient. These were the three properties that you used in Algebra 2. So I'll give you a few minutes to write those down and we'll talk about them some more. If the log of any base, so log whatever base of 1 is 0 because it's saying a to what power equals 1. So anytime that's a 1, it's equal to 0. And if it's log base a of a, so log base 3 of 3, log base 5 of 5, that's always equal to 1. You don't necessarily have to memorize those things because we can work them out in any problem and get that. Those are just a couple results that do come up periodically. There are two other properties that we didn't talk about so much in Algebra 2, but I am going to go ahead and mention. And those will be the two properties that we're actually practicing today. For a positive base other than 1, a to the log base a of m power equals m. You want to make sure you get these written down. And the second one, log base a of a to the r power equals r. Essentially what this tells us is that the exponential and the log cancel each other out. So they're inverses, like we saw in our last section. When things are the total opposites and they undo each other, those are inverses. The reason, I can give you a little blurb to kind of explain why this is. This first one is written in exponential form. If I wanted to write it as a log, you would have log, the base of the log is the base of the exponential, of m equals log base a of m. So if we wrote this as an exponential, we see that if we take this exponential and write it in terms of a log, we see that it's true. What we're going to think about when I see problems like this, if I said like 3 to the log base 3 of 7 power, what would the answer be? Okay. A to the log base a of m power equals m. So 3 to the log base 3 of 7 power equals 7. If you have the same base on your exponential and the log, they essentially just cancel each other out. And that's your answer. So it works from the other direction too. And this is a log. If I were trying to write this log as an exponential, you see you would have a to the r power equals a to the r. So we see that it works. In terms of an example, if I said log base a of a to the 7, or let's not do base, let's do 3's. Log base 3 of 3 to the 7 equals 7. The log base 3 and the 3 drop one another. and so you just get 7 for your answer. Okay, so I'm going to use these two properties for a couple examples today, and then the product, quotient, and power, we have them in our notes. That's what we'll pick up with tomorrow. So if I asked you to solve these things, 3, x equals 3 to the log base 3 of 8 power. Equals 8. The 3 and the log base 3 would cancel. That's our property. Second one, if I said x equals log base 4 of the cube root of 16. Let's rewrite that a bit. A cube root is like what power? I could rewrite 16 as what? So what you really have is log base 4 of 4 to the 2/3 power, so what's this equal? 2/3. I'm going to put 3 up here, give you just a few seconds to write down the answers for each, and then I'm done. So here are your 3 columns. Tell me what those things mean. Is log 2 to the log base 2 of pi. What's A equal to? Pi, the 2 and the log base 2 would drop. What's B? The log base 2 and the 0.2 cancel. What's C? The log base 3 and the 3 drop. Are we okay with that? This is my stopping point for today. There is a handout posted on Classroom, and you've got the rest of the class to work on.